The log file logs transactions that change the structure of a volume, like creating a directory. The USN journal has a longer history. And volume shadow copies are real important. These came out with Windows 2000 Server. It automatically backs up certain things so you can recover them. Now it automatically generates backups of the entire volume, including your personal data. So it's pretty nice. The only problem is it has old versions of things, so if you delete something, it doesn't have old versions, or at least they're not easy to get to. But it's extremely useful for examiners because you'll find things from the past in there, which someone might have deleted. And so you can do VSS admin, list shadows, and it will show you what shadow copies are available, and Forensic Tools will do it too. VSS admin is the built-in Microsoft tool to do it. I think that's what we have here. Yeah, VSS admin, list shadow. All right. So that's called the shadow copy. Mirror the entire file system available within the linked directory, and just like the recycle bin, Windows sets aside a certain portion of the drive to use for these copies, and only keeps the changes. So they only stay around for a while. Eventually they're erased. There's a bunch of tools to inspect them, and they're in Velociraptor. Windows Collectors VSS will collect the volume shadow copies from the machine. Now there's a thing called the redirector, because you might make a request. For example, you might want to install a 32-bit app on 64-bit Windows. There are a ton of them. If you do that, the 32-bit app will attempt to install, it will attempt to change registry keys and file locations that do not exist because they have changed. So if it tried to just ram them into the 64-bit registry that's not the same, it would create weird problems. So what they do is they detect when a 32-bit program is trying to write to system folders and redirect them and lie to them. So it tries to write to C Windows System 32. It goes to C Windows SysWow 64, which is Windows on Windows. So it lies to the program like a virtual machine. It thinks it's writing to C Windows System 32, but it really goes somewhere else. And when it tries to read stuff it's written to C Windows System 32, it knows what lie it told, so it can show it that again. It does the same thing to the registry. That's called the redirector. This means that if you were to run a 32-bit tool like an antivirus, it might not be able to scan the whole file system because it can't reach files. It's like it's running in a virtual machine. It can only reach the ones it's allowed to reach. And then there's prefetch. Now this really bothered everybody when Windows XP came out. You would get a machine with like 4 gigs of RAM, which was considered an outrageous amount then. Then you'd go into Task Manager, and it's all in use. And they say, what's going on here? My previous machine with only 1 gig of RAM was doing fine. Now it's wasting all these extra gigs I bought. What it does, it doesn't want to leave the memory sitting there doing nothing. There's a fundamental problem with all modern processors. The processor is much, much faster than the RAM. So this is a huge problem, and this is what led to one of the Apple security flaws a week or so ago. There are all these tricks to try to guess what you're going to want later and make sure it's ready in some cache or somewhere in RAM, because the hard drive is really slow. The RAM is slower, is faster but still slow. The processor is much, much faster. So a lot of the time your processor is just waiting for data to come in from one of these slow devices. And so to speed up performance, they try to anticipate your needs. So prefetch contains a list of the last 128 things that have been launched on this machine. And whenever you're not doing anything else, it is automatically loading them into RAM in case you might launch them again. So it remembers everything you've been doing. It tries to prepare them for you. And it has these binary files that end up in PF, system boot prefetch, sitting around prefetch files in the prefetch folder. So it's a wonderful record of what's been going on in the machine, and that's what it's for. So anyway, even if the executable has been deleted recently, it's still in the prefetch folder for a while. So you can tell when something was run, when it was most recently run, how many times it was run. So it's really quite useful if you want to examine what's been going on in the machine. And so you can do, there's a tool called Win Prefetch View that will let you see it, because the prefetch files themselves are not readable. They're not simple shortcuts. There's some stupid binary format you have to untangle. But of course, Velociraptor has it. You can just do Window Forensics Prefetch. It will fetch it and then convert it into a readable format for you. So it's very nice. So I say that when you make these all-purpose tools, they really make life much easier. So then there's event logs. Event logs have been around for a really long time. And They do record logon attempts, which is really important. Creation, start, and stop of system services and applications, the audit policy, user permissions, and things installed by installed applications like antivirus and such. There's a lot of good information in the logs, but the logs are really, really hard to use. Just opening a folder and opening a file creates hundreds of entries in the logs. They have these event IDs that are hard to understand, so it can be pretty frustrating. These are the 3 basic logs that were available ever since Windows 2000. Application, system, and security. Security is, of course, the most obvious one we're interested in, with log on and log off attempts. The system one has driver loads, and then applications are whatever the applications chose to log by that app developer, so it varies. So you can get them. They're all log file locations are stored in a registry key, and if you go there, you'll find them. They're these EVTX databases, and it's here, see Windows System 32 Win EVT logs. Those are where they are. All right. There's logs here for Task Scheduler, Windows Firewall, App Logger, Terminal Services. Lots of things are here in addition to the normal event logs. These extra features have newer event logs just for one application. And so, to understand an event, you have its source and its event ID number. And you can get a lot just by Googling those. So you have a logon event ID 540. So that tells you what this is. This tells you who logged in was the administrator, what network address they came in over. There's several different types of login. Login type 3 must be the one over network where they remotely log in. So there's various types of logins. And here's what Event Viewer has to say. An account successfully logged in. Login information, login type 5. And impersonation level system. So it looks like they managed to elevate as system. It must be some internal services. This is services.exe logged in as system to do something. So you get this kind of information from Event Viewer, a lot of details. So login ID is the session identifier. And you have login type. Here's the login types. 3 is a network login. 2 is interactive. From the keyboard, then there's batch, service, and proxy. And other ones too. So you got the process that initiated the login, the authentication package, the workstation, and source network address. All useful information to see who's using your machine. So typically, your attackers will come in, get execution on the machine, then they will steal credentials, and then they will do lateral movement to other machines in your network. And lateral movement is a step you really want to catch. If you can stop them there, you can limit the harm they do. So they often use stolen credentials, and watching login events is often a clue for this. So here's an attacker, Bob, gets interactive access to a Windows workstation through a backdoor. That's joined to a domain. The backdoor runs under the context of the domain user. So they managed to steal credentials with something like Mimikatz or something. They get a local administrator and a domain administrator account. Now, they mount the C share and then uses psexec to remotely execute a command on the other workstation to infect it with malware. Then they get a remote desktop session to another server and browse to an IIS server that requires you to log in. So doing these various things as they try to move through your network, and all those are going to create logs. This one's going to create a network login. This one's going to create another login created here. This is the one to use the network tool psexec, I think. Yeah, psexec logs on and then starts a process on another machine. This is going to do a remote interactive, and this is going to do another kind of login. As you've logged in to authenticate, you have permissions to see a folder. So all these things are in the login logs. So you can also look here to see if user account has been created or deleted. And policy changes, like changing audit policies, when they try to stop logging or erase logs. You'll see events here recording that. The audit log was cleared is recorded here. A thing to be aware of. Process auditing is not on by default. If you turn it on, it'll then put an event in the security log every time a process is executed, which is nice, but it creates a lot of events. And you can have service events also that record this. A lot of things, malware is often a service. And here's the logs for psexec, the thing that launches. psexec service was successfully sent to start, entered the running state, was stopped, entered the stop state, sort of thing you'll see. So suspicious things. unusual people using PSExec, bad service names, errors from malicious binaries that were deleted, but still referenced by service. That means you had some imperfect attempt to remove malware and it's still trying to launch the malware. So you look for antivirus is, of course, extremely handy. If that goes off, you have some clue what's going on and when it happened. Now you can determine a period of time. You should probably increase your log files. They don't keep a long time by default. They have a certain size, and then they new event erase the old events. Unfortunately, this EVT format database gets corrupt a lot. The same thing is true of Microsoft Outlook email databases. They get corrupt all the time. In both cases, Microsoft ships tools to decorrupt them. I don't know why this happens. I remember when they had, the blue screen of death and the restore mode and everything on Windows, they raised this up at Apple. Shall we have that? And Steve Jobs said, no, you'll make it not crash in the first place. This is a different philosophy. Microsoft has all these repair tools for all the disasters. So here's some tools. Event Viewer lets you see them. PS Log List will let you dump to plain text logs. And there's a lot of other tools like Log Parser and such. Like I say, as far as I'm concerned, they're all kind of obsolete because now we got Velociraptor. And we have Sysmon, which is so much better because Sysmon doesn't give you this overwhelming old logging. It gives you new logs that only log about a dozen events, nice simple events like file opened, process launched, and so on, with just the information you need, like who did it, what is the MD5 hash, things like that are not present in the normal Windows logs and much more handy. So the Sysmon is very good, and we're using it in the projects for that reason. Yeah. Now let me go take a look at the things here. Baidu, yeah. All right, fair enough. All right, so then there's scheduled tasks. This is the equivalent of Linux cron jobs. So you can create them from the command line at 1625, execute this command. It will run with the privileges of you. Now in Windows XP Home Edition, it will run as system. So that was pretty amusing. So you can just a simple way to escalate yourself to system. Just at 5 minutes from now, CMD. Anyway, they fixed that with patch service pack 1. So anyway, here you can run this thing. You can tell it every Monday, Tuesday, and Wednesday. You can tell it on the server named Alpha, run it. You can remotely refer to a server. Of course, you'll have to have credentials to log into that server sufficient to do it. But anyway, you can schedule all sorts of tasks. It can take a lot of them. At one time, we had a practice exam for a certification test, and I put it on a network server and let students get in. And I wanted my students to have ways to reserve it. So I set up 30 times 24 times, 30 times 24 scheduled jobs for every day of the month and every hour of the day, and it would change the password every hour. What my scheduled jobs did, and you would change the password you want so every student could get into that time. You can have like hundreds of these scheduled jobs. They work fine. Anyway, you can do it with the SCH tasks command too, as opposed to the @ command. This lets you control it in more detail. When you're done, it creates job files in system root task, a separate job file for every job, which is very much like the way Linux does it. There's just a folder for cron jobs. So there's logs in a task scheduler, and it records start and completion of tasks. There's also event logs, recording when scheduled tasks stop and start. This is real important because a lot of persistence mechanisms use scheduled tasks. You schedule it to phone home. This, I don't know exactly how the Chinese did it to Google, but in the original Aurora attack is the time I heard that they would put malware on your machine that would sleep for up to 3 years and then wake up. So you would get it in your backups and everything, and you think you're clean, and then blam, you're under remote control again. And I don't know if they did it with scheduled tasks, but you could. I think you could. I've never tried making something delayed for 3 years, but maybe it's possible. All right, so job file is, again, a binary file. The strings will show user information and path. This is the way Microsoft used to do everything. It would make a custom binary file for every job. And only in 2008 did they finally realize this is kind of horrible and we should just use like plain XML for everything. But in the early days, every bit was precious, and you made a proprietary binary format with the bits encoding everything. So there's a thing called job file parser to let you see what's in there. And see, here's some flags like don't start if on batteries and things like that. These are all the parameters you can have in scheduled tasks. And there's a log that shows you this job started, this job finished, and so on. and you can see it in Event Viewer. Here's user registered task scheduler, updated task scheduler task, launched the instance of the task, received a new message from the task requesting to launch it, and so on. This is what I say when I mean every little thing turns into many, many little tiny events in the Windows event log, enough to drive you crazy, which is why Sysmon is so much nicer. Job process launched, blam. And so you can, of course, access them in Velociraptor. Task Scheduler will give you a list of all the scheduled tasks, and you're doing it in the projects. So, let's check for comments. No new ones. All right, let's do the third Kahoot, which is somewhere. I may have lost my Kahoots. Oh, here they are. All right. Good. 12A3. You're forming pretty fast. Or maybe it's a different student. All right, a complete copy of a volume. It's the shadow copy. To be fair, I think it only has the differences between your current state and the volume. Otherwise, it would never fit. But you can reconstruct the whole volume from there. All right, anyway, all right. All right. What prevents your 32-bit app from messing up your 64-bit system? That's the redirector that redirects its read and write operations to folders that are different than where it thinks they are. Right, where are login attempts recorded? That's the security log. You might think it would be the system, but it's more of a security issue. All right, which one of these has one instance per task? Those are job files. All right, good. All right, which one of these persists until a reboot? The job files actually vanish and are recreated by the scheduled task process every time you reboot. recording.